a couple of years ago, the Reverse Logistics Association started a process to create standards for reverse logistics. We came up with this idea of a special QR quick response based code, these 3D codes, 2D codes, that we selected that because it can handle 4,000 characters, which is 4 times the capacity of a barcode. Because it's optical scan, it doesn't need power. You can actually get a box in, and without having to plug in a monitor, plug in a power cord, you can actually find a lot of data about the product. And we thought that this would actually very much help with the process of reverse logistics. We thought that there would be benefits to consumers, repair centers, refurbishers, recyclers, and they would all benefit from having additional information. We've looked at the process. We concluded that there were actually about 10 different domains in which additional information would facilitate business practice throughout the life cycle of the product. Shipping and customs would be able to not have to deal with all the paperwork. You could put a lot of the information from customs needs onto a label. Manufacturers could put all of their GS1, their UPC codes, along with proprietary stuff, all of your certifications. Ron, in a previous presentation, came up with a photograph of a disk drive that had about 20 labels on it, all of which could actually be digitized and put into one QR code. We realized, in fact, our initial sort of take on this was that it would be enormously useful for recycling, where hazardous materials and dangerous materials could be identified. You got 4,000 characters after all, and you can have more than one label on a product. But it would also help with pre-sale support. You could actually have on the outside of the box a label that you could scan and would go to a video or to a chat. Lots of pre-sale support. Of course, your basic product information, and you could also automate product warranty registration and even warranty reverse RMAs, return merchandise authorizations. But the thing that seemed to hit most of the people we talked to who were in the industry was a digital toe tag. The notion that you would be able to take a box in and create an optically scanned label that would follow the life of a repair product seemed to be the hot button that companies like Intel, Dell, Google, and a bunch of major corporations have said this would really help us in expediting where we are going and what we need to do to make our business practices more efficient. The notion is that when a product is returned, a digital file is created. Everybody's doing that. But frequently what happens is that digital file gets separated from the physical device that is being returned. Every manufacturer has this type of a database, but because it's not standardized, the problem comes where you have different repair centers. Intel said that they have 5 repair centers. They don't speak the same language. They don't use the same software. And since they don't serve one company exclusively, that one company cannot impose sort of standard software across it. But if the industry comes up with standard fields and standard structures for these databases, then there can be harmony and efficiency in that sense of efficient use of data. The contents of a digital toe tag we came up with is we decided that there needed to be 2 basic fields. One, a pointer to this digital record that's in the cloud, so that when it does get separated, the person can optically scan and say, oh, here's where the record is. But then also we decided that there could be a diagnostic event record that would be a second one that would give more detail of a product that was optically scanned, so you didn't need power, and you could make the triage process more efficient. The time and date of the product, all of this stuff can be optically scanned and make the process much, much easier. We decided that the QR label could contain the following information useful at the receiving depot, and that it would go on from there. All of this is based on the concept that there would still be a master repair record, that Each manufacturer would have to define how much data they wanted to keep. We're not about telling people what they have to do. We're defining a minimum number of fields that will make it interoperable and make sure that some of the stuff is standardized so that automation can be improved and efficiency improved. The notion is that each time a product is returned, there would be a diagnostic repair record. It's created and posted upon completion of the master repair record. So these are these two things. The one is optically scanned. The master repair record is in the cloud. This is what it would look like. We think it ought to be read so that it would be recognizable as a repair record. In a few minutes, you'll see how this actually would work. So the digital event record has just a minimal amount of information in it. The date received, a listing of error codes found, disposition code from a coded list, and the identity of the receiving site as a separate field, so that the minimum amount of information would be there and the record itself would be very small. And you'll see that in operation in just a little bit here from Eurosoft. Actually, I can skip over this for now. Working with Eurosoft and a few others, we realized that the basis for our codes is the fact that computers especially have a certain number of components that are then in triage put through testing, so that the basis of it is to standardize on what these components are and give them a number that would be easily trackable. This is extensible, so if there are more things that come out, for instance, right now, accelerators and biometric stuff, Field 4, I mean, those are new, and who knows what will be out there tomorrow. So this is an extensible list, but we will standardize on it so that it can be developed into more serious applications. The other thing that we can standardize on is the product disposition. Real simple, we can just have simple codes. Again, this is extensible, but the value is that we are standardizing on it so that every company knows that a 00 means no problem found, return to inventory. And that's perfectly fine as long as you're doing it that way. When you scan the code, if you look at the bottom of the screen, you see the code there, which is these 5 fields, would generate this type of a list that's there on the model of the phone. We think that this, for a reader, would be very useful information, and you could develop, as you will see in a few minutes, full applications to support this notion. If you push that button down there, it actually would take you to that master repair record. It's just a URL that's in the cloud. You don't have to have all of the information. Again, pushing the buttons on that digital event record. Repair notes can be as extensive because it's in the cloud. It's a URL. It can be as extensive as you want. And you can do lots of things with this as the manufacturer desires. So this was our idea, and Eurosoft heard about it, and I'm going to introduce them at this point because they took what we had done and they moved it to the next level of actually making an application that embodies it. Sharon Richards is one of the directors of that. I'd like to introduce Sharon, who can introduce her company, and she's got one of her engineers, Rick Dietz, who's actually going to, I think, walk us through their presentation, which shows how they've taken this and made it into an actual commercially available application. Sharon?
Thank you, Ken. Thank you very much. Right, so what I'm going to be doing is pretty much watching what Rick has to say. We've been working with the RLA group for about a month now, and Rick and our other engineers have come up with a design and probably more of a concept at the moment with some action in design that will gather up these error codes and allow computer manufacturing through to service, through to refurbishing, allowing traceability of what's going on with that computer so that you know what the disposition is at any time. And I think that pretty much covers it from my end as far as introduction goes, because we really want to stay with the subject matter today. Again, we'll be happy to take any questions offline, by email, and discuss further. So let's carry on from that standpoint. So Rick, are you ready?
Yes. Can everybody hear me okay? Yep. Can you hear me?
You come through 5 by 5.
All righty. I'm going to go ahead and jump in and go to slide 2 here. We can see it's Eurosoft. Okay, slide 2, where we talk a little bit about the objectives. Again, reviewing capture the diagnostic errors into the RLA system is the overall objective that we're trying to reach for with this, and provide the error output specifically as squirrel code data. That's going to involve converting our standard Eurosoft error outputs to these generic codes. Some of the future considerations we've also discussed include incorporate Eurosoft error codes themselves, our longer error codes that contain more detail for more complete diagnostic event data, and to incorporate proprietary diagnostic error codes from other manufacturers. Now, the proposed solution we've been talking about with Ken and amongst ourselves here is, again, to gather specifically our QA-Win system information XML output, which has all the information about the data for extended data to be captured, and more to this conversation, the test result information to parse this data down, filter it, and sort it out to a string that's suitable for the RLA squirrel toe tag. And again, some of the future considerations we've been talking about include things like displaying the squirrel code on the screen so you can actually scan it with an application, getting the diagnostic error events into the cloud that way. And the way this would work in a flow chart, just starting out, let's say starting out the upper left here, an operator would scan a unit and to get some more information on it, and then decides if it's worth running diagnostics on it. If they do decide that no diagnostics are needed, they would enter their disposition code and process the unit, and it would go on. If they do decide that diagnostics are needed, the unit is sent to the next person to run the diagnostics. So we go down on the left there, we run diagnostics. If the diagnostics fail, the diagnostics would output a formatted file, and that would contain a string that conforms to this new standard. And I'll talk a little bit more about the output standard in just a minute, but the diagnostics outputted file would be put out to a network drive where a service would harvest this and send it to a printer. And this is where we are in the initial talks with this. Just a little side note on this. We would be running our diagnostics in a bootable PE, Windows PE. So you wouldn't rely on the hard drive operating system, the installed operating system there. You just boot to PE and run your diags. But since we'll be running in PE, that provides a lot of challenge to be able to print from that environment. So right now we're talking about sending that output to a network drive that it can be grabbed and printed from there. So once the toe tag is printed, it can be stuck on the unit, perhaps inside the case lid for desktops and towers, and maybe on the bottom side, underneath for laptops and tablets. Then the toe tag could be scanned to update the master repair record up on the cloud. Then the unit would go to repair. They'd scan it, know they have to replace a drive. They'd fix the unit, run the diags pass, and a new toe tag would be printed out and stuck over that old toe tag that had the failure record on it. And again, at that time, update the master repair record on the cloud. A future consideration is also to include, like I said, a print preview of the squirrel code so that anytime a failure happens, you got the code on the screen, and any tool that an operator would have can easily be used to scan that code, print out your label, update your master repair record, and carry on. So this slide is just a graphical depiction of how diagnostics can fit into a refurbishment process that involves actually booting up the machine and running diagnostics. We understand you're not going to want to do that when the unit's received. They're not going to want to take it out and boot it up every time. So when you do run diagnostics, you can actually print the label, stick it on the unit, and create an actual toe tag that would look something like that. And then the unit would go to repair. Toe tag is scanned again. The unit is repaired. Diags pass, and a new toe tag is applied, like a yellow one over a red one, for example. And that's kind of how we visualize this fitting into a refurbishment process. So that's just an early version. It's ongoing. It's under development as we go along. We're open for input as always. And I'm going to go through the next few slides, talk a little bit about how the diagnostic outputs themselves can be boiled down to the standards that we're talking about here. This is pretty much the same as what Ken showed us earlier with the generic error codes here. And example, in this scenario, an audio and a monitor failure both happen. So we have a 3 and a 17 from this chart. The resulting output line, this D51 line, could look like this line at the bottom here. We have an element for the date, then an element for the failures, the 3 and 17 that are highlighted there, and then a depot ID and operator ID. On a scanner, this information could appear as this slide here, where you actually see the information formatted nicely and it's readable. If we take it a step further, we can say that there could be extended error codes. In this example, we've taken one step deeper into our own extended error codes from Eurosoft and included some of that more information. In this example, we can see we have an audio, the audio section of the table and the monitor section of the table. Each one of these containing multiple messages for the various failures that can happen to those devices. And when a failure happens on those devices in this scenario, you can see the resulting output line at the bottom of this slide, where you'd have the category of the device, the extended error message number, that hexadecimal number there, and that's tying back to this table here as a subtable. So the reader could display something like this, where you get an audio failure with a description. So in this case, we know the sound could not be played, and the operator has chosen to fail the monitor. And that's a pretty quick summary of what we've been talking about doing here at Eurosoft and what we're going to be offering. And the next couple slides, I just want to talk about real quick, run through a little background on Eurosoft. We've been in business for over 35 years. I've been doing diagnostics since 1986. And we have research and development locations in the UK, USA, and India. We do business with a lot of people. We have a lot of great clients. We not only do business with a lot of great companies out there, we do a lot of business with a lot of great organizations like the Ministry of Defense and the Department of Defense. In our diagnostic offerings, we have PC Builder, which is more optimized for manufacturing and refurbishing. And we also offer our service and repair packages, PC Check and QA Plus Win, our self-booting diagnostic and our Windows-based diagnostic, respectively. Our PC Builder solution is pretty much a complete package for manufacturing. It gives you the management framework for full scripted capabilities, automatic configuration check, automatic script application, automatic imaging, handles your DPKs automatically. And we help people install it and set up the process for them. We perform not just as a product there, but a lot as a consultancy as well. And integrated with our PC Builder solution is our Windows-based diagnostics, QA Plus Win. The test matrix of QA Plus Win is quite extensive. Almost all the tests we have will run in Windows PE, with only a handful that need full Windows to run, and those are the tests listed in blue text here. You can see we have a ton of tests. And PC Check and QA Win are individual test packages. They're all deployable. PC Check is self-booting. QA Plus Win is our Windows-based diagnostic again. Unlimited test script capability and flexible outputs, again, with XML output. We have PDF output and text output.
And squirrel code output.
And squirrel code output, yes, indeed. And with the PC Check diagnostic software, again, it's a self-booting solution. You don't even need a hard drive to run PC Check. That makes it really flexible. You can test Windows machines, Linux machines. It basically comes in two parts. One is a Windows-based mastering application to set up your media. You can make your media so your operators don't have to make any choices. You just put the media in, boot it, and it runs the test that you want to run. And I'll skip back to it. And again, with PC check outputs, we have the XML outputs, TXT outputs, and soon to be sQRrl outputs. And the test matrix for PC check is pretty good too. It's pretty extensive, and with the unlimited scripting capability you have with PC check, you can run these in any order, any number. The parameters are extremely extensive for control. QA-Win, a Windows-based diagnostic solution, again, also has full scripting capabilities. It's not a self-booting diagnostic, but we can set it to automatically run your predetermined scripts when you launch it, making it usable by any factory operators. And this is a little screenshot of some of the QA-Win diagnostic views that we have there. We offer sensor monitoring and benchmarking there. And again, PDF reports and squirrel code output. And again, that's the matrix for Windows again for both Windows and Windows PE. Only the test listed in blue require full Windows to run, just because you need those extended device drivers that come in full Windows, like for the gyroscope, display adapters, and those type of things. And that's pretty much the spiel that I have for right now. I appreciate you guys listening to that very rough presentation today. And I think we're going to turn it back to Ken in case we have any more questions about what we've just went through here.
Well, I think what we're seeing is that the development of squirrel codes as a standard is easily to adapt and to integrate in with existing products. And in this particular case, a very thorough and a very complete diagnostic system that will support and generate these real small efficient codes that can create the digital toe tag that so many of the RLA members have expressed interest in. Are there any questions from anybody?
Yes, sir. This is Jonathan Chapman from Nashville. Will we be able to receive a copy of these presentations?
Galen, you want to give instructions on that? Galen?
If you're a member of the association, the video presentation is available to you, okay?
Okay, thank you.
If not, you can contact us directly, I'm sure.
Okay, thank you.
Jonathan, it's Sharon Richards here. I can also interject that we're working on a follow-up paper that we'll be sending out to people that have attended, and also a few that are waiting for a follow-up presentation that we have. So there'll be more coverage. But I do highly recommend that people join the RLA from just to get the inside information, the scoop of where all these reverse logistics ideas are going. It's quite beneficial.
Also, Sharon and I have agreed that we would co-author a article for the RLA magazine that should be available upcoming for one of the next issues.
Thanks for that reminder, Ken. It's absolutely true. I better hurry up. He's right.
Any other questions?
Should we, go ahead.
So this is Mike from Intel. So it's interesting with the diagnostic codes. One of the things that we found is trying to keep the diagnostic code data set up together, because obviously technology is always changing. It's interesting that from the depth of analysis you go to, having a standard code that says the audio fails is not as helpful, but when you started bringing in the additional codes that say, here's some of the comments that the engineer made, you can put things like, it failed after 10 minutes, so it doesn't fail straight away, those types of things. Have you thought about how you would keep the squirrel code extensions either updated so that when people come to load it, I was thinking that either you have a web page that will download the latest set of codes. So anyone who has your software package, if you decide to change your code or add codes to it, you'll be able to download that from a website, and then when you read it, it would read the latest codes as well.
Yeah, Mike, this is Bruce from Information, and just want to interject that as part of the whole idea with the sQRrl codes, we'll be updating the names of the fields on the readers, like the cell phone that we were displaying in there, the smartphone. So
right.
that is very much part of the process and the vision that they'll be updated as the standard updates.
I also would say that what we're trying to do is define a minimal set of essential fields, if you will, for essential fields where we realize that manufacturers have different needs, and we expect this system to be totally extensible so that manufacturers can fit it to their own particular requirements for analytics and data. We do not expect that all of the databases will look alike. As long as they have the minimal set of fields in it, they can add as much as they need.
Yeah, and I don't know if it was clear or not from the presentation, but the idea is that the last repair record pretty much in total will be on the QR code, and that this master repair record is up in the cloud and is available by just clicking on a button. But it's not every single bit of data for all history is stored on that code because the detail and the amount would become overwhelming.
Yeah, the concern I have is that there are some companies that we deal with do not have an outward-facing website.
Correct.
So especially some of the Chinese companies will be a little bit restricted on actually wanting to post out because of the threat of people posting back in. So sometimes they're very restricted on getting through their firewall to be able to pull some of that information out. So as obviously there are ways of getting around that. It's just how, if you want more information, if the company doesn't have an out-facing firewall that they can allow people to come into, how are people going to be able to get the benefit of it? But that's something we can think about long term.
Yeah, we should. That's a great point. We should talk about how much data, working with you guys and maybe get Eurosoft or some similar company involved, how much historical data you would need on the label to make sense for that sort of situation. We were just being a little bit conservative, saying that the record that's got all data for all instances of going through repair facilities might get too big, so part of it could just be stored off in the cloud, but there's no reason that it couldn't be more on the label as long as we don't exceed those 4,000 characters.
Well, two comments on that. One, I think the limit of 4,000 characters these days will change rather quickly as these codes start to proliferate. The people who make these scanners have said that the only reason that it handles only 4,000 characters is because they've been a little bit lazy and nobody's needed more than 4,000 characters. The resolution capacity of modern optics says that 4,000 is only a temporary barrier. Secondly, I also think that there could well develop an industry where even for those people who have firewall issues, there could be a store and forward service that they could subscribe to that would ease their security issues.
All right.
Well, and to Mike's point or question, I want to make sure that I sort of understand it as clearly as I need to. That if you think back to one of the first slides Ken had up there, where he had a bunch of hexagons. In the tags that get encoded in a sQRrl code, there can be the standard ones that we were using, the example of the audio and the video and whatever. But if there are industry specific, codes and terms that are already, widely circulated within an industry, we don't need to be in the middle of reinventing any wheels, and we just want people to just be able to go ahead and use the language and the terminology they already use. And I think, is that the M letter identifier?
Yeah.
Ken? So, so Mike, were you saying, well, if somebody updates a set of error codes and they can't download a new set of error codes because of the firewall, or?
No, it's just it's just with technology changing. We have our own data system, and we've worked with a number of depots for the screening information. So it's very much like the technical codes that you were looking there, where they will screen a product. They won't actually necessarily identify the fault, but more of the symptom. In doing that, as technology has grown, we found that every now and again we have to release a new set of codes, otherwise people start bucketing into an old code like it's a generic other, and it doesn't mean anything. So the ability is, as you work with these companies, is a way of being able to get that detailed information to say, here is a new piece of code, and how do we easily get it into creating a standard. I'm trying to explain myself, probably not very well. Creating a standard tends to give you an outline and a framework for everything to hang off of. But I think when we do the more detailed code, is maybe having something within the system that says, here is a tag that says this is a list of all the latest fail codes, and if you go to that, there is a website. You can download all the codes and update your translator on your phone to say, okay, this will now tell you what the latest ones are, so that people don't always have to, people could actually use it to have an evolving set of codes all the time. We bring out a brand new product, there's a new device on it. When they start testing for that new device, we've got to create a new code because it works in a totally different way than anything else. So being able to have that ability to instantly update that code and be able to say, okay, it's this piece, this optical transmitter is now failing, and it's always showing blue instead of red and green. You know, that type of thing would help.
So on the side of somebody who's trying to understand what the results of the test or the results of the codes mean, that's easily disseminated, because we'll need to, every time there's a change like that, you know, for digital toe tag, we'll need to, you know, release an updated version of the software, so that when you scan it, and, you know, in those the slides that we saw there, where we saw, like, here's the, you know, the code version, and here's the thing you can read in English to better understand what's going on. That software will have to sort of have an updated release every time there's a new error code. But if you're talking about, okay, so how do the people in the testing facility know that, hey, there's a new error code, and you don't have to lump it into this one, you know, catch-all bucket anymore. We've got specialized codes for all these different potential errors with this new, you know, device, or this new, you know, error sort of thing.
Rick, can you go back to the slide? You still got control of it. Go back to the slide with your extended codes.
Going back there now.
How long is a dictionary? Well, ours is fully extensible. Go back to the previous slide there, Rick.
This one here?
When you come out with a new device, it becomes number 32. It's automatically extensible. We post it, and most of the readers should be capable of automatically updating this just off of the RLA website.
Yeah, well, it's not even RLA website. The software that we're writing for the readers, every time there's a new squirrel code, if you will, it gets the new code for it, like 32 or something, whatever, and it gets the new name for it, whatever it happens to be. And it promulgates that, it pushes that out to every device automatically. This is not a manual process. Now, in Mike's case, where internet access is restricted, we may need to take a different approach to getting the devices updated. But it's as of right now, for anything that can ever connect to the internet in any way, it would automatically update.
So go back 2 more slides, back to your extended slide there, Rick. So does this type of information satisfy what you're asking about, Mike?
Yeah, it gives you that extra detail that enables. Again, part of your comment was that you could land all of this additional information in the cloud. And that's great if you have someone that can actually get out of his company into somebody else's to actually pull it down. So that's the dilemma we've had in the past, is being able to enable, and again, for us, this is taking this toe tag and then we ship a product down into China. There's a Chinese tech sitting on a bench somewhere trying to understand what's wrong with this board, and he may not have that ability to be able to easily get out of the company to pick out through the internet to be able to pick out what this code means. So it's how
do you update those texts now?
We don't. That's the issue we have. They get a board and all they do is they retest it the same way as we've already tested it. And our big concern and the reason why we're interested in this is we want to be able to give them that information, because we said we've already invested $3 or $4 in testing this product already before we shipped it to them. They could get the benefit of saying, you know, here is what we found. And if there's valuable information in there that says, you know, this is a heat issued problem, we found it didn't fail until it was warm. You pass that to the tech, he's not going to run it for 2 seconds, find it didn't fail, and then pass it through, and we get it back in the field later with the same fault in it because he didn't know that it needed to be tested a little bit longer. And it's that piece of the information. And I think everything I've seen here looks really great. I'm looking for the systematic process that enables us to get the more detailed elements either on the toe tag or in a place where someone in China can actually read it, because they're the ones that are going to be doing the repair.
My sense is that with 4,000 characters, this particular string looks to be about 50 characters there at the bottom of the screen. That means that we've only got 3,950 to go. Usually my guess is that there's no more than 1 or 2 problems with the device. I think that using this as a pro forma, there's plenty of room in a sQRrl code to have as much information as you need. It's just a matter of defining these codes a little bit more thoroughly, which also would help you with the repair process, in that needing 10 minutes, needing to run it 10 minutes to get it warm is a pretty easy standardized code that is to create, that you can read in Korean or Chinese.
Yes.
Well,
I agree.
Is there anything that would prevent, so the tech, you know, wherever in the world runs the test and comes up with these 2 error codes, is there anything that would prevent them from just including that English character string the operator has chosen to fail the device based on the appearance of the test, or it needs to run 10 minutes before it fails or whatever? Is there anything that would prevent them from just including 50 characters or 100 characters or whatever of English text explaining it? You know, I mean, that the code. What?
They don't.
Well, sure.
So you want to use the code that can be translated into multiple languages, so that people who are lower level don't have to have English literacy to intercommunicate.
Mike, I'm sure there must be a way that these locations receive updates for their computers that are doing all these diagnostic things. There's a way to mail them a CD or something?
Yeah, no, as I said, it was just something I was looking for us to be able to consider, because we've had issues in the past in getting updates in and out. And also, I didn't want to be into a point where we have a code that gets updated every 6 months and then passed out to everyone else, because there are times when, if you look across all of the business companies with all the new products that they're releasing, having that structural ability to add and modify the codes in a very easy process would actually help sell this as an idea of saying, yeah, it is flexible enough that you don't have to wait 3 months for the latest update or get everyone to agree what the codes are. The other question I'd like to ask is, have you looked at any visual codes in here? Do you have any of those already? Because a lot of the
visual codes.
So a lot of the times when we're doing testing, it may be a case that there isn't a functional test that fails because the pin's been broken off. So you can really say floppy drive failed because there's no pins on the board. You know that we have. So on some of ours we have a visual we do a visual inspection and then a functional inspection, and we will identify on the visual inspection that there is a screwdriver scratch through one of the traces that will identify that this board's been damaged in a way that you can't functionally test it, or the pins have been broken so you can't functionally test one of the ports. And we will also put that in there, so when we send it to the repair agent, they know that they've got to replace the connector head or something. Now, we've had that before where it gets out to the repair site, and the repair site goes through all their functional tests and don't pick up the fact, because they have a tester that tests it from the bottom of the board through a pin matrix. So they don't actually notice that there is no connector on the other side. They've still got the solder pads on the back side of the board. And they'll test it completely, say it's perfectly fine, put it back in the box, ship it back out, and then they go to plug it in and say, oh, there's no connector on here. You know, so sometimes that's the other side of our testing or our screening process, which will identify visual. And I didn't know if you covered those at all.
At the extended level, we do it at the premium product with the PC Builder, and it's a physical inspection, just as you say. But I would really want to consider having another field in there that would just be, comment, and it would be physical inspection. You'd be able to write in that particular, device issue, something like that. That would make it more flexible again. But, as we pointed out from the very beginning, the top layer is to standardize this code format, however you want to look at the scroll code, so that there's consistency all the time. We all know the minimum standard, and then the second and third element would be, like we're saying with the Eurosoft diagnostics as an example, giving a more comprehensive review of what's going on with the hardware. And then on a third level is even more information, just like you've suggested, Michael, to say, okay, commentary, we want this added too. And I just want to roll back to your other question. I think what you were, we have a couple pretty large clients in China also, and I would suggest that from some standpoints, you're right, it's closed doors. And one thought that comes to mind is having, as an example, like a CRM, we have a hosted or a non-hosted system. In this case, it's a database, really, so that it could be pulled and updated, later on. So that way, no one's breaking the rules. They have an IT management that's making sure who can and who can't access. I think that would be a possible solution. And I've seen it work in a similar way with another company out there. So I can't see that that's not overcomable.
Yeah, and again, I wasn't trying to put it's just as we try to flesh out this standard and extend its influence, it may be something we want to be thinking of. So when we put those hooks into the framework to say, and this is how you can do these types of things, because I think as the companies try to adopt it, if we've already covered some of those areas, it allows the adoptions to run much quicker, because now they're not looking for another way of modifying it to make it work. So
exactly.
My hope is that what we've come up with is an extensible framework, and the framework enables these types of extensions to be added simply and without complexity, because again, as I said earlier, how long is a dictionary? It's as long as you need it. And there is an infinite number of fields that we can create, and some of them will become obsolete over time. Like, at some point or the other in history, I'm sure the issue of a floppy disk, people will look at that and say, what's a floppy disk?
Very true. I was aging myself when I raised that, yeah.
Yeah.
But in reverse logistics, that will be around for a while.
We'll still need that error code to be there, because a lot of things that come back are old, and somebody needs to look at this thing and say, what's this? Is this a coffee cup holder?
Yeah. It's got a retractable coffee cup holder in the disk. It's like some people don't even know what a DVD drive is anymore, because they moved off of that already.
Yeah. So I think we're coming out of time. Are there any other questions? Ron, you got any final words of wisdom?
I don't think so. I would like to encourage anybody who has any questions about anything to to send an email to me or to Ken, and that the whole idea here is to create an open standard to make it be as widely useful to as many people in the reverse logistics world as possible. And so we want to get input and commentary from as many people as we can. And so if you would like to join in our merry band here, as we've got a lot going on here on this committee, especially related to this, and Sharon made a nice little plug there for joining the RLA for anybody who's on the call who's not a member. You're welcome to participate and call in and send us emails and ask us questions, and we would we want as much input as we can get. And
this webinar is eventually going to be up on the RLA site on YouTube, correct?
Yes.
Good. Do you have any final words? I guess you should close it off.
I just have a quick question. Sorry, I was on mute earlier and wasn't coming through. But for Rick, when you're showing your examples in your diagram, your QR code label was fairly large. It was what, 2 inches by 2 inches or something like that. Is that was that because you think you need it that large to hold the data, or was there a reason for choosing that size of a label?
It was just pretty much arbitrary, just as a starting point. We're thinking they could be a lot smaller, of course, and this actually gets back to a point that Ken made earlier about how small they can be. They can actually be a lot smaller. And the limiting factor there is the optical quality of the cameras and the devices. If they can increase them just a little bit, it can go well beyond 4,000 characters even. Isn't that right, Ken?
That's right. And right now, QR codes are as small as about less than ½ an inch. The one that is on GoPro that they use is, what's the size of that, Bruce?
It's really small.
It's much smaller than ½ inch.
I'm not even sure that's a QR code.
Yeah, it's a 3/8 inch label.
Yeah, so it could be much smaller than the 2 by 2 that I showed. I think I just made it that big just for illustrative purposes is all.
Oh yeah, okay, yeah. I was just curious whether you're.
It's pretty gaudy.
Yeah, I'm trying to show on my screen. There's a 3/8 inch label. I don't think you can see it on the GoPro unit. Okay.
Is that the one inside the battery compartment?
Yes.
Great, thanks.
Yeah.
No further questions, Your Honor.
well, thank you. Thank you. So just for some housekeeping, Rick and Sharon, if you'll just stay online for a second, I'll show you guys how to turn on your video and stuff after everyone's gone. Okay?
Yeah, that'd be great. That'd be great. So I got all dressed up.
All right. Okay. And again, there were 18 people online today for this presentation. Wow. So thank you all. Okay. So is that in? So we should shut down the meeting, Ken or Ron?
That's okay with me.
I think
very good.
Then. All right. Okay. Thanks, everybody.
Thank you all for participating.
Thank you.
Thanks, guys.
Bye.